In this video, I will explain how to solve a free fall problem in physics that involves tossing an object straight into the air. So let's jump right into an example. This says, a man stands on top of a 10-meter tower and shoots an arrow straight up with an initial velocity of 50 meters per second. Now, we want to find 4 different things right here. The first thing we want to find is find the time that it takes to reach the highest point. So I've drawn a little sketch of our situation here. We have this man on top of a 10-meter tower, and he shoots this arrow into the sky with an initial velocity, let's say v sub I, our initial velocity, is 50 meters per second. So the first thing we want to know is, what's the time that it will take to reach the highest point? So the highest point, that would be this point right here, just before the arrow starts to turn around and fall back to the earth. So to solve this type of problem, we're going to use our kinematic equations, which these are equations that we can use in physics when we have constant acceleration. So in this case, when we have an object that's being launched into the air and then it's falling back to the ground, we do have constant acceleration because that's just the acceleration of gravity. So we know that the acceleration of gravity, that's negative 9.8 meters per second. So this is a value that we have to know in order to solve these types of problems. So to find the time that it takes to reach the highest point, one other thing that's really useful to know is at this highest point right here, the velocity, which we're going to call the final velocity in this case, so on the arrow's journey from this guy up to this point, the final velocity is going to be 0 temporarily. So if we know these 3 variables right here, if we take a look at our kinematic equations, it looks like the very first equation would be the easiest to solve for time, which is t in these equations. So let's go ahead and write that out. We'll say, for this first question, we have v sub f, the final velocity, is equal to the initial velocity plus acceleration times time. So again, we said the final velocity at this point, when the arrow reaches the highest point, temporarily the final velocity is 0. So we'll say 0 is equal to the initial velocity we know is 50, plus the acceleration, that's negative 9.8, and we're trying to solve for time, so we're multiplying that by time. So to solve for time, we'll just move the time to the left-hand side, so we'll say 9.8t is equal to 50, and to solve for time, we can divide both sides by 9.8, and we find that these cancel out. We're left with t is equal to 50 divided by 9.8, that's about 5.1. So 5.1 seconds is how long it will take for this arrow to reach this highest point right here. So let's go ahead and write that down right here, and I'll clear a little bit of space. Okay, question number 2 says, find the max height of the arrow. So to find the max height, to find this height right here, really what we want to know is, what is the displacement from the starting point of the arrow down here to this max height? So what is this displacement right here, which we write as delta y, the displacement of the arrow. So in this case, we want to choose one of the kinematic equations that involves displacement, and it turns out that we could actually use equation 2, 3, or 4 to solve for this problem because we have all of these variables. So it looks like the easiest one to do would be this 4th equation right here. So let's go ahead and use this equation. So let's write question 2. We're going to use displacement is equal to 1/2 times the initial velocity plus the final velocity times time, which we just found. So we'll say the displacement is equal to 1/2 times the initial velocity is 50. The final velocity, so the point where it reaches this highest point, that's 0. So we'll say plus 0 times time, which we know is 5.1. So we get 1/2 times 50 plus 0, so that's 25. So we have 25 times 5.1, and that turns out to be 127.5. So 127.5 meters is this displacement right here, but we also have to add the 10 meters right here, which is the height of the tower. So if we're talking about the max height, we want to know the max height from the ground. So we'll do 127.5 plus 10. So our final answer is going to be 137.5 meters. That's the max height that this arrow will achieve. So let's go ahead and write that up here. Okay, question 3 says, find the speed of the arrow just before hitting the ground. So just before the arrow hits the ground down here, we want to know what is the speed that the arrow is traveling at. So in this case, we're going to call this speed right here our final velocity. So we want to know what's the final velocity just before hitting the ground. So to solve this problem, if we're looking at our kinematic equations, there's a few different ones we could choose. Let's try number 3 for this one. So let's say For question 3, we're going to use the final velocity squared is equal to the initial velocity squared plus 2 times the acceleration times the displacement. So the final velocity squared, we don't know that. That's what we're trying to figure out. But it will be equal to the initial velocity squared. So we know the initial velocity is 50. That's the velocity the arrow is shot at. So 50 squared plus 2 times a. Again, a is always negative 9.8. That's gravity. Times the displacement. So for the displacement, remember, displacement is just the final position minus the initial position. So the final position that we're talking about is right here. Let's call that 0 meters. And notice that the initial position is up here at the top of the tower, which is 10 meters. So our displacement is going to be 0 minus 10. So that's negative 10. So we'll say times negative 10. So if we simplify a little bit, we find that the final velocity squared is equal to, so this right-hand side turns out to be 2,696. And to solve for the final velocity, we'll just take the square root of each side. And we'll find that the final velocity is equal to, we'll end up with plus or minus 51.92. And we're talking about velocity, so that's meters per second. And because the arrow is traveling downwards, we're going to say that the final velocity is negative. So we're not going to use the positive result. So our final answer is going to be negative 51.92. So let's go ahead and write that up here. All right, now our very last question says, find the total flight time. Now to solve this question, there's a few different kinematic equations we could use. Why don't we use equation number 2 right here? So we'll say, for question number 4, we're going to use the displacement of the arrow is equal to the initial velocity times time plus 1/2 times the acceleration times time squared. So let's fill in what we know. So again, the displacement of the arrow, that's going to be negative 10. And that's equal to the initial velocity is 50. The time, we don't know, we're trying to solve that. And then we have plus 1/2 times acceleration, again that's negative 9.8, and we'll have times time squared. So let's go ahead and move all of our variables to the left-hand side of the equation. So 1/2 times negative 9.8, that's negative 4.9 t squared. So when we move it over here, we'll have positive 4.9 t squared. And then we'll have minus 50t, and we'll have minus 10 is equal to 0. So we want to solve for t. So to solve this one, we're going to use the quadratic equation, which is this equation right here. Negative b plus or minus, we have b squared minus 4ac, and that's all divided by 2a. So let's fill in what we know. So negative b, so the b in this equation is negative 50. So a negative 50 is a positive 50. And then we have plus or minus, we'll have b squared, so negative 50 squared, minus 4 times a is 4.9, times c. c is the negative 10 right here. So we'll say negative 10. And that's all divided by 2 times a, so 2 times 4.9. So if we simplify a little bit, here's what we get. We get 50 plus or minus. Inside the square root, that turns out to be 51.92. And then in the denominator, we have 2 times 4.9, which is 9.8. Now remember, we're solving for time here. So if we do 50 minus 51.92, we're going to end up with a negative answer. So we're not going to use that because time can't be negative. So our only answer is going to be 50 plus 51.92. So that's 101.92, and that's divided by 9.8, and that turns out to be 10.4. And remember, we're talking about time, so we're talking about seconds in this case. So our final answer is that the arrow, the total flight time of the arrow is 10.4 seconds. So that is how you can solve a free fall problem in physics that involves tossing or throwing an object into the air.